Another quick short video on I2c. So this is using Great Cloud Basic as in slave mode. This video is really confusing. I'm going to try my best to keep it simple. What have I got? I've got a 16F937 acting as an I2c Slave. That's programmed using Great Cloud Basic. Over here I've got a pickaxe, 18M2, it's on a test board, and it's connected to the I2c bus, along with a whole load of other devices. What I've actually got connected is, and I'll just correct this whilst I'm here, that's connected into there. Okay. What I've actually got is this slave connected to my terminal, so we can see some outputs, and out of the pickaxe I've got a debugger, so I can see what's happening. This is quite confusing. So what we're going to do, we've got hanging off the 1937 a pot. It's got a pot value, and it's going to put it on the screen. Okay, so I'll show you that to start with. And here it is. Okay, we've got a pot value. In actual fact, we'll put the out value on the screen so we can see it. All right, and we'll put some code in here. Okay, pot value, so that you can actually believe that I'm actually doing this. Not that you wouldn't anyway. And then we're going to compile that up in a moment. Okay, so basically what this is doing, this is a slave device. Its address is this, which is equivalent to, it pretends it's device. I picked a random number, put it in binary. It thinks it's address 7E. Okay, all right, at 0x7e. And so I am a slave device 7E. I'm reading the pot value on port 0. I'm starting the I2c in slave mode. It then says get some information. This is a new function that is not in the old code, so this is I2. It's a receive mode. It receive some information. This is my address. This is the address I've received if it's true. Okay, and I'll give you I'll document this up, but essentially this enables you to ignore anything that is not intended for you. So if it's not intended for your slave device, it just ignores it. So if it is for this address, then it picks it up. It then returns it in in this value here, and it actually does some error handling. So basically, this is the function subroutine. My address returned the read address that you've actually received in here, and then you can say do a test. If it's intended for me, if this address is intended for my address, then I'll do some stuff. And it then receives some data from the other device called the pickaxe. It then it receives a time and puts it in a variable. Puts a variable in time, and then it receives an address. So the pickaxe is going to be sending out two numbers. It's going to send out a time and address and its read address. Okay. And then I'm going to send back 1, 2, 3, 4, 5 values. I'm going to respond back with the address that I think I am. I'm going to respond back with the time that I received. That gives me a bit of a sync. I'm going to receive with the address that I think I am, and a counter that's just been incremented for every time I go around, and then the out value, which is the pot value. Okay. So what's happening out on the pickaxe is, at the moment, we can have a look in the camera to see what's actually happening. We'll just start this up to see what's actually happening on the. This is my little debugger, my protocol analyzer, and basically at the moment the pickaxe is looking for device 3F. Okay, let's just make sure, because it's a 7-bit address, not an 8-bit address. If I take my old calculator and put the address 3F in it, and because I lose the top piece, I do. Oh, sorry. 3F, I multiply that by 2 just to give me the top bit. Oh, it's looking for address 7E, so it's looking for address 7E, can't find it. Okay, and so if I program my microchip, I erased it, we can see it go live. We should just have enough time to do it. Program it. There we go, write that out. And we'll see that all of a sudden there's some chatter. Good, there's some chatter on the I2c bus. So what's happening? In my terminal, it says that I have got pickaxe time received was 18. Oh, my code isn't very nice long. We'll change that very quickly. Pot value. We'll just put a tab in on it. We'll just tab that out. It's not very nice, but it's saying that it's going to. I'm receiving these numbers 1 through to 49, and it's actually the seconds. It's the seconds coming from the other device. So this is a screen here that's looking into the slave device. Okay. What I'll do is quickly reprogram that. Import on that. It's just a quick reset. Good. There we go. So it's receiving some values. Now my pot value, I've got a pot over here. I rotate the pot. You can see that the pot value is changing. Okay. So what's happening on the other end? Because this is the actual, that's the master. Here is my piece of code. It's essentially really simple. It says exactly what I said. This is the actual, go and get some data. It says the device address is here. I send the time, and then I expect 5 variables back called B. These are the variable names, okay? I could do it slightly differently. And if I program that, by pressing F5, okay, all this stops over here because it's been programmed. So the microchip, that is the pickaxe is actually being programmed, so it's not sending out any values. We'll see it actually throw a debugger up, and we can see them side by side. No, we can't. How do I get them side by side? I press F6. There we go. And if you look in there here, this is the pickaxe master device. It's sending out a time. Here it is. We know it's talking to this one because it's not talking to any other device. It's quite clear. It's sending out a time of value 25, and it matches up with that number there. Look. 28 is 20. So you can see the time has been received by the I2c Slave. The pot value here of 194 has been and this debug is looking on the values that have been received in the pickaxe. Here's the value of 192. So it's correct. It's on its 85th well, when it gets to the 90th mark, that's how many iterations. And it thinks it's reading from address 7E, and its read address, so its read and write address is 7E 7F, which is quite correct. And the pickaxe timer is here, like 64. So it's sending out a number of time. It receives it over here at 70, and then it gets sent back, and it receives it back into this variable here. So you can do a verification. So let's just prove it's all working by turning the power off. Okay. We turn the power off. Reset the screen. Turn it all back on. Right, we got time is incrementing through every second. The pot value is sitting here, and the count value is the 9th iteration, 12th, 15th, etc. So we can see that this is actually a closed loop. If I turned off how can I do this? If I turn the clock off, turn the clock off of the I2c program chip, I get FFs back, do I? Yep, I get FFs back because it's getting no response. So I get no values back. There's nothing coming out on the terminal, on the green terminal. I reconnect it, turn the clock back on, and it says it's on iteration 44, and which should have been. It didn't. It did lose some time. Look, there we go. So some pickaxe time was lost. It was offline for 13 seconds. But it works. So really simple piece of code. Okay, really simple. But this is the killer piece. I2c Slave receive, it actually looked for its address. It didn't use it. We didn't have that piece of code. That is all new, and it's a new piece of functionality. So what I wanted to demonstrate was Great Code Basic I2c Slave, mainly because I keep forgetting it. Okay, so I've done this as an ABM one for myself, but I'll call that a wrap.